Okay, I found the error. So it turns out our math is right in that there's no issues with our dynamics. Um, I checked this by simply plotting you know the original stuff. Um, Turns out the error. Actually, here, let me just do this. I'll run it once. Okay, this should stop it from drawing. There we go. This makes sense, right? Because the way quaternions work is you represent the last three represent the axis of rotation, and the first value represents the amount to rotate about that axis. And so right now we're trying to rotate about the z-axis. So the last number should not be zero. The other two should be zero, and then the first number should just be a function of how big our time step is. And this makes sense to us, right? Which means our math is right. This is an expected value. Which leads after a little bit of process of elimination, if we know that our simulation is working right, it means that our problem is in drawing it. So somewhere in here we have our error. And something that I didn't mention is that there's a lot of notations for quaternions, right? You can have the first number be the scalar, or you can have the last number be the scalar. Um, right, like how much to rotate about, right? The first three could be the rotation axes, or the last three could be the rotation axes. And it turns out within my quaternion attitude file, I had it set up with the other notation, where I think it was like the rotation was the last number rather than the first. Or I had a typo in here. To get around this, just go to Google. Don't copy paste code like I do. Just check it once. And I went and implemented this one, which is, this is the format that we know is working, right? This is our unit quaternion is with A, B, C, and D. And then I'll just put this over here, put this here. And if you actually go through and try to, where did the rotation matrix go? Shoot, where did it go? Where did it go? There it is. And so if you go into the original video and look at this, like it's wrong, right? I had the wrong value there. But let me try squeezing this into one. It's not gonna squeeze. Oh well. I'll just move this up and then off. There we go. Barely fits in. Okay, but yeah, like this was the error, is that this matrix that I had was wrong. It is now correct. um, but if you're trying to recreate this, just search it up. Use a reference on the internet. Don't try to copy paste code and hope it works all the time, right? Sometimes someone uses a different format than you do. Yeah, just double check your work. And now that I've done and finished this, I can go back. Let me get rid of that one display line I had added to check. There we go. And now if we run this, we can see it's rotating about the z-axis. And if we go here and check, let me just go up a little, that we are in fact rotating about the z-axis. And then if we were to go about and try to do the x-axis, boom, right now it's rotating about the x-axis. And we know this is working because our value is positive. If we apply the right-hand rule, we'll see that a positive rotation would be counterclockwise as it is now, and the positive value for omega would be out, like going from here outwards. And so this is a bit of a sanity check, right? We know that this works. And yeah, that's going to be the correction for this video. Yeah, with that, okay, yeah, goodbye.